Hi Trisha, Professor Sebastian. Just want to send you a video here where we can talk about your exam one. And of course, if you have any questions, please don't hesitate to reach out to me. And also, I would keep my written feedback here that you can see on the left, on top of your notes that you took during the exam, and this video. So when you're studying for the final exam, hopefully that will help you. First of all, the important stuff I'm sure for you is that you want to know how your score improved. Now, I actually did this a couple days ago, so I'm just now making this video. Your MyMathLab score before I did my review was 54.67%. Of course, we know MyMathLab doesn't do a great job of looking at your work. It doesn't do any job of looking at your work for partial credit, etc. So after my review, you now have a score of 73.07. When I did this a couple days ago, your current percentage grade was 76.96, but I just took a quick glance at it, and because of doing some homework since, etc., you're now at 78.11. So you're at the C plus, B minus range right now. Just kind of keep at it. Don't worry about the letter grade. Letter grade would never be worse than what you see in the syllabus, but it could be better based on how things end up at the end of the semester. Okay, so number one, you got completely correct, so no need to talk about it. Number two, let's see what number two we got here. So number two, you're supposed to find this domain. Okay, now when you kind of did some stuff here, I wasn't quite sure what you were doing. You really did some bad algebra. It's like you tried to factor this x squared out of the square root and put it in front of the square root, then x squared times the square root of minus 49. There's no such thing. So you can't do that kind of algebra. So I wanted to walk you through and show you. There's two things you have to think about when you're looking for the domain of this function. First of all, anything inside of a square root has to be positive or 0. So in other words, x squared minus 49 has to be greater than or equal to 0, which means that x has to be greater than or equal to 7, or x has to be less than or equal to minus 7. And then the denominator of a rational type function, which is like a fraction, the denominator can never be 0. So we want to make sure that we find out where that denominator is 0. So just solving this to be equal to 0, bring the 24 over, cancel the negative signs, you get x squared minus 49 equals 24. And then square both sides, x squared minus 49 can't equal 576, which means that x squared can't equal 625, which means that x can't be plus or minus 25. So we know that x has to be less than or equal to minus 7, so we can go from minus infinity all the way to negative 25, but we can't use negative 25, so we have to have parentheses around it, in union with negative 25 to negative 7, but we put a square bracket around negative 7 because we do include it. In union with 7 to 25, including 7, not 25, and then in union with 25 to infinity, and that takes care of your entire domain, putting an interval notation. Okay, so I really couldn't increase your score because there was no work there of this kind, and you did some bad algebra here. There wasn't anything for me to help you there with that score. Problem 3, there was no work, but when I was looking at this, I felt like I could get some of your thinking process down here. The last part, you look at the x, not the y, for the intervals of increase or decrease. So when you're looking at this function, you have the functions increasing from negative infinity to 5, right? So it's increasing from negative infinity to 0. We're talking about the x's. What x is the interval for x. You happen to glance up here when y is 5, and that's what you put. Same here, 5 to infinity. It should be 0 to infinity. So because of that, I just felt like there's no reason, you seem to know what you're doing. I think your eyes glanced in the wrong direction. So we went from 0.5 to 0.75 there. Question 4, you had completely correct already. When that happens and you do have work, I just write a check mark with MML. Means MyMathLab already graded it as fully correct. All right, question 5. Another graphing type problem. You got A, B, you missed part C. So in part C, this is a vertical shift. So we're starting with the function x squared. And when it's x plus a constant, that means we shift 1 unit to the left, which you did correctly. You got the horizontal shift correctly. But the vertical shift, for some reason, you went down 2. This is plus 2. That means you want to come up 2 units. So I gave you half credit for getting the horizontal shift right, but not the vertical shift on that. So your score went from 0.75 to 0.88. Let's see, question 6. Question 6, again, this is a graphing type problem. So this 4 means to shift up 4 units. So you got the vertical shift correct. You went up 4, but this 1 would mean shift 1 unit to the right. You're switching around those in your head again. Okay, so what we want to do is go 1 unit to the right. So this is the correct answer for shifting the square root of x function. Not this one. You had the vertical shift right, not the horizontal shift. So we went a score of 0 to 0.5 in number 6. So even though you didn't have work, I could kind of see what you were doing with those graphing type problems. Okay, so question 7. Let's see. Do you have 7 out of order here for me? I can't remember where 7 was. 7's all the way here. You had it on the last page. So when we look at 7, yeah, that and that. So the problem is cosine of x is minus 15/17. We know you were also told that x is in the third quadrant, right? From pi to 3 pi over 2. So that means I drew this in the third quadrant. Here's my angle x, but I have to draw this reference triangle. And when I know the cosine is negative 15 over 17, that means the side adjacent is negative 15. The hypotenuse is 17. The hypotenuse is always positive. So this becomes an 8, 15, 17 right triangle, or you could use Pythagorean's theorem to figure out that it's 8. You kind of almost had it. You thought it was 6. I'm not sure how that happened with your calculations here. But so then once you have the sides of the triangle, you can get that the sine of x is opposite over hypotenuse, negative 8 over 17. Right? That's this guy. And then the tangent of x would be opposite over adjacent. Negative 8 over negative 15 would be positive 8/15. So you had some work that was kind of along the right lines, so I thought, okay, it's fair to go from 0 to 0.5 here. That's question 7. Let's see what else is on this page to remind myself. 8 is next down here because you had no work, but I couldn't increase the score here, but I do wanted to show you how to do this. You have to use what's called the double angle identity. So it even tells you, evaluate cosine of 7 pi over 12, but know that that's the same as cosine of pi over 4 plus chi over 3. So once I have cosine of A plus B, right, I know that cosine of A plus B is cosine A cosine B minus sine A sine B. That's a double angle identity for cosine of A plus B. So then you work those out, simplify it. That's question 8. I really couldn't give you any credit there. You had an answer that doesn't make sense with what's going on and no work. Okay, so 9. Looks like we'll go back to the original front page, I think. Yeah, 9 right here. Okay, so 9 was you had to go through this work, which you were doing pretty good. And then you just dropped the minus sign somehow. So you added a minus sign here. I'm not sure what happened. So factor out an h. You got h times minus 72 minus h right here. This should be a positive h. Then the h's cancel. You get minus 72 minus h. Take the limit as h goes to 0. That ends up with minus 72. And then that messes up your equation for the tangent line because that should be minus 72. Otherwise, you did it correctly, though. So because you really had a good idea on how to do this, I went from a score of 0 to 0.9 out of 1. All right, so then 10, 11, and 12, and actually 13. Well, no, let's see. 10, 11, 12 for sure were already correct. So I just marked them that way. Also 13 was already correct. So I didn't need to check those that closely. I got to 14. So again, you didn't have any, you said come back to, didn't make it back. I don't know if it was time-wise or forgot about it, but 14, here's what you need to think. All you have to think of is the closest distance from either endpoint of this interval to 2 is delta. So delta is either the square root of 7 minus 2 or 2 minus 1, the distances. So 2 minus 1 is 1. The square root of 7 is about, I don't know, 2.5 or 2.7 or something, but that's less than 1. Square root of 7 minus 2, just plug it into your calculator. So the value of delta is square root of 7 minus 2. I couldn't do anything there to help you score-wise, but let's see, 15. Okay, so 15 again, I felt like you had the right idea. This becomes a little complicated down here once you get the 1 over x. You had this correct. Keep it to 4 decimals because we wanted to, everything has to be 4 decimals at the end. So then you just flip everything. So it should just be that x is between right here. You flip these guys like this. 1 over 0.4955, 1 over, and it changes the direction of the inequality signs as well. So now you know that x is less than 2.0181, but greater than 1.9822. So your interval is 1.9822 to 2.0181. Then the smallest distance from 2 gives you delta. So this distance from 2 is 0.0181. This distance from 2 is 0.0178. Right? So delta then is the 0.0178. That's your distance. So I did increase that score from 0 to 0.67. You didn't talk about finding delta in this problem, but I think you just kind of didn't get to it because you got confused in this situation up here. All right, that's 15. Let's see, is there 16? So you have 17 here. So 16 was already correct, 17. Again, I couldn't increase because you were missing the graph, but let's look at this and see what happened here. So choosing the correct graph, that's all you missed was choosing the correct graph. So what's the problem here? We have f of x is x cubed everywhere except x equals minus 2. So we know it has the right shape of x cubed. But at minus 2, which if it was actually on x cubed, that would be negative 8, right? So it's not. So we have to put in, you would have an open circle down here and a closed circle up here because it's minus 2. So that's what this guy is, which is the correct answer. You flip these around. All right, but that's important to know which one is the open and which one's the closed dot. So I really couldn't increase your score on that one. But you should understand that. 18, you already had correct. 19, again, I couldn't increase the score here because you got continuity correct. You can just see that you have to pick up your pencil here at 2 when I'm drawing it to come up and pull in this color in this dot and then come back down. But is it defined at 2? Sure, it's defined at 2. It's defined to be 3. And that's also right here in the definition. F of x when x is 2 is 3. So that's why it jumps up here. And we put that solid dot to say that at 2 the function is 3. So it's defined at 3. It's just not continuous. Again, can't change much there. 20. Did you have work 20 anywhere? Let's see. No, let's see, to work 20 anywhere. Let me see what happened here. Okay, so in 20, what happened was I didn't mark it on your sheet here, I guess. So, but what I did was I said, okay, when she put in this minus 5 to 7, I got an idea that she knew to factor the denominator and say, okay, I know the denominator, this factors into x minus 5 times x minus 7. So really, that means that x can't be 5 or 7. Otherwise, the denominator becomes 0. So your domain is anything but x equals 5 or x equals 7. So as interval notation, you write it this way. Minus infinity to 5 don't include 5, and then 5 to 7 don't include 5 or 7, and then 7 to infinity don't include 7. That's how you're supposed to write it. I had an idea that you kind of knew about factoring denominator from this, etc. So I said, okay, let me give you some points there. So we went from 0 to 0.5 on that one. All right, that was number 20. I'm going to stop this video because I can only make a video that's less than 15 minutes long with my free version of screencast here. So I'm going to stop it and do another video to finish this up for you. We just finished problem 20.